Hi everyone, so in this video I'm going to talk about sets. Now, I want you to look at this code and I want you to tell me what it is going to print out. And if you have not yet done the reading, you should go and make sure and do the reading on this subject, and then you can try to answer this question. So what is this going to print out? Well, in this code there is a set that has some numbers in it, and then that set gets printed out. But one thing that you need to be aware of about this data structure is that it does not allow for duplicate elements. So even though I have several 5s in that line of code, when I actually go to run this and print out that data structure, only one 5 shows up. And it's because the duplicates are not allowed in a set, it eliminates the duplicate elements and only keeps one of the 5s. Let's see. Yeah, so 5s is the only one where when I tried to define it where there were duplicates and it got rid of those. So anyways, the set data structure is another kind of data structure that you can use in this class from this point on. So what data structures have I talked about previously? I talked about lists and I talked about dictionaries. So now there's another one that you'll be able to kind of put into your tool belt, and if the problem that you need to solve would be best solved with this data structure, then use it. So what exactly is this and how does it differ from a dictionary, or how does it differ from a list? Well, one way that you can think about it is it's kind of like a dictionary but without the values. So in a dictionary there was this key value mapping where you could have the keys mapping to values and you were not allowed to have duplicate keys. Well, with a set, you are not allowed to have duplicate elements in a set, so you can kind of think about it like a dictionary if you just didn't have the values that it maps to. You can also just think about it conceptually as sort of a bag of elements, right? If you just need some set of elements just to a collection of items, a collection of things in your structure, you can use a set. So when it comes to writing code that utilizes sets, what are some examples of what it would look like? So when you go to create a set, and this is actually yet another reason why it's helpful to think about it kind of in how does it differ from a dictionary, because when you create a set, except for empty sets are an exception to the rule, but when you create a set that actually has elements predefined in it, you use the curly braces. So this is an example of creating a set in Python, and that over there is an example of creating a dictionary. So notice it still uses the curly braces, and it looks kind of like creating the set, just without the colons and without the values that those map to. If we want to loop through the elements in a set and let's say print out each of those letters, you can also use a for loop, just like you could for a dictionary, and you can just print out those elements. So far, other than the values, kind of similar to a dictionary. But some differences are coming up on this slide, right? So if we need to remove something from a set, we can call the remove function to just get rid of that value. If we need to add something to a set, that we use the add function. Now, why is it that we don't use the function called append? Why don't we just be consistent with our function terminology, and why don't we use the same name as we used for lists? Well, lists are an ordered data structure, so append makes sense as a name of a way to add to it, because since there's an order that is kind of kept track of inside of a list, it makes sense to say append, which kind of implies that you're putting something at the end. With a set, you should not rely on there being it being ordered. Internally behind the scenes, it's possible that whoever implemented the set might choose to keep a particular order, but you as a programmer should not rely on a set actually maintaining its order as the code is running and as you need to do stuff with your set. So rather than talking about in terms of adding something to the end with the word append, we just say add, because again, you're kind of thinking about this as like a bag of elements where you can just add things to that bag or remove things from that bag, but you should not conceptually think about this as a sequence of elements. You should just think of it as a grouping of elements. Now, what about that special case for creating an empty set? Because if you use the curly brackets to create a set that already has elements in it, why is it that we can't do this for an empty one? Well, the reason we can't do this is because how would Python know the difference between creating an empty dictionary and an empty set? When there's stuff in it, Python can tell the difference because it can tell based on, well, if you put keys with colons and then values, that probably means you meant a dictionary. And if you don't have the colons and the values, then well, let's assume that you meant a list. I'm sorry, not a list, a set instead, right? Not a list, a set. But when it comes to an empty one, how would Python be able to tell the difference? So if you need to create an empty set, what you do I have it in the slide? Well, what you need to do is you need to say set with parentheses there. So let's actually go and I'll try to show if I were to create that, and then if we were to print the type of ds2, that indicates that it thinks it's a dictionary. So if we want to actually create an empty set that perhaps, for whatever reason in your code, if you want to start with an empty set, you want to say that, and then you can see it says set. But if I were to create a set that actually already had 3 elements in it, or let's just say 2 elements in it, and I hit run, then it's able to determine that that's a set because it didn't see the colon and then the value after each of those numbers. So there we go. There's a few of the differences in what makes a set different from a dictionary in terms of the syntax of writing things out. So a couple of practice problems for you. I want you to look at that code. There's a set, and then some things are attempted to be added and removed to and from that set. So what will happen when this runs? What will happen? So let me bring it over. We'll run it, and then we can talk about it. So we actually get an error, in particular a key error. So if you try to remove something from a set and that element does not exist in that, you'll get an error, at least if you try to remove it with the remove function. So the error is coming from line 5 because at that point, line 5, 7 does not exist in the numbers set, and we attempted to remove it. So if I had said, the in keyword also works, so if 7 in numbers, to check if it was there first, we could get around that error, and then that is what would print out. So be careful, both with dictionaries and with sets and with lists even, about how you are removing elements in case you need to do that. All right, what about this? What if I change that to, a few changes there, right? What would this print out instead? So what did I change? Let's see, I changed line 4 to be discard instead of add, and then we also have an add, or really I just inserted this line, discard 5. Add 1 is still there. I tried discard words and add 2. So I changed a few of the lines in there. Technically, that line just got, this line there, line 4, just got bumped down to 5. So let's see. Let's see if you get the right answer. Well, you can check if you get the right answer. So this one, if I run it, doesn't produce an error. But why doesn't it produce an error? Because we try to use this function called discard, or actually wait, yeah, we try to use discard with the string words with an S, which does not exist in the set because the string word without the S exists in there. So if you use the discard function, this is one where it will attempt to remove it, like if I change that to match, it does remove word. But if the value doesn't exist in the set, instead of throwing an error, it will just allow the program to continue to run. So use that. That's another option if you want to remove something and you want it removed if it's in there, and if it's not in there, you don't want to make a fuss about it. You just want to have your code keep running. Okay, so what would this print? Here's an example of looping code that would loop through a set to print out the answer. So what would this print? So this will print, whoops, stop that. Oh shoot, I think I need to reopen Mu. Let's go to the Mu editor. So basically, this is going to loop through the elements in the set, right, and print it out. But let me make this bigger and zoom. All right. But we have a problem actually, and I should have paid closer attention so I would have recognized that this would be a problem. But this actually is problematic because what I'm doing there is I'm doing a for loop trying to, if names had been a list, and I'll actually show that, if this had been a list, this would actually work out all right because basically if it's a list, you're trying to write a loop that goes through the indexes and then grabs the string at each index and prints it out. But with sets, because you're not supposed to rely on the ordering, you actually can't do indexing with a set. So we get an error, type error, set object does not support indexing. So if we want to go through and write a loop that just goes and prints everything in a set, we could change this to be for name in names. We still can use a for loop, we just have to avoid indexing. And then we could say name. So if I run this multiple times, the order is not always the same on each run. So this is one of those things where, again, you should not rely on the elements in a set being at a particular order. Just think about it as a bag of elements that cannot have duplicates. All right. So yeah, doesn't support indexing, right? Like it says or shows the error on the slide. So don't rely on indexing and don't rely on elements being saved in order in a set. So instead, right, like I showed, you can do something like this to loop through names. All right, so another difference between a dictionary is with a dictionary we had this concept of this associative sort of mapping, right? But in a set, we don't have that associativity. So is there an equivalent? Like how do I say, in a dictionary, if I wanted to get me what's associated with C, you could do something like that. Or even in a list, if you wanted to get elements in a list, you could use indexing to grab things at different locations. With the set, there isn't really a need to have an operation like that because it's just a bag of things, or at least you can think about it like a bag of things. Literally, it's a bunch of ones and zeros in your computer, right? But at least in Python computer program. There's also the concept of sets kind of in general in mathematics too. But with sets, you don't really need an operation like that. So with sets, you can have a set and you can do things like, well, tell me if an element is in my set or not. Or hey, loop through the elements in my set and let's print them out or let's do something with them. But you don't really have to worry about this associative mapping, right, that dictionaries have, and even lists also sort of kind of have that associative mapping with indexes. So anyway, so before we get to that next question, actually, I'll back up. One of the things you might be thinking as I'm going through this is like, okay, so Ben's telling me all about this new data structure, but what's the point of it? Why do we have this? We're going to do a few more practice problems, but I'm also going to, in a future video, go over an example that actually utilizes sets, and there are some real-world use cases where having this data structure is actually useful. Having a data structure where order is not necessarily preserved and where duplicate elements are not allowed. So if by the end of this video, if you're still not totally clear why sets are useful, stay tuned for a future video. Okay, so another practice, we have this letters list, so a bunch of letter grades in there, and we also have what starts as an empty set, but things are potentially going to get added and removed to and from that set. And then something prints out at the end. So what is this going to print? Well, let's think about this code. So the set starts out as empty, and of course, there's a bunch of letters that start in that list. Now, the list is iterated through, but there's this if-else that basically asks if L, whatever the grade is that you're currently looking at, letter, if that's in the grades set already, then remove it. Else, or in other words, if it's not already in the set, then add it. So basically, the first time it sees a letter, it will, if it's the first time it's seeing an A, it will add that letter. But then if it sees it a second time, and it's already in the grades set, it will remove it. And then, let's see, in our case, A only shows up twice, but let's pretend it showed up a third time. If it showed up a third time, then it would add it again. So essentially, the way you can think about this is, from this letters list, if a letter appears an even number of times, it should not end up in the grades set by the time we get down to that final print. If it shows up an odd number of times, it should still be there when we get to printing out. So if that's true, then what should still be in grades by the end? So not A, because A shows up an even number of times. Not C, because C shows up an even number of times. But E only shows up once, and B shows up 3 times. So it should just be those two in grades. So let's see if that is correct. There we go. So that's the answer. And if you got the answer in the other order, that's all right too. If I ran this enough times, there we go, right? The order switches. And it's because grades is a set in this example. All right. Here's another one that has to do with, it actually has a delete for deleting from grade counts. So we have a set and we have a dictionary. So what is this going to do? What is going to happen? All right, so for this one, I'm not going to go through the answer in real depth, but just so you can see, I'm going to run it real quick. That's the final answer. I'm not going to go through the solution in depth, but I do have a few more practice problems to give you. All right, so let's pretend that the problem you need to solve is the following. Let's say I want you to open up a text file that has a whole bunch of people's names in it. First and last name, and there's just one first-last name pair per line. What I want you to do is I want you to count how many unique names there are in this file. So for example, some of these names might show up multiple times. Like for example, Chris Paul shows up at least, let's see, 1, 2, I think in this example, 3 times in this file. So you'd want to count that as only one unique name. So basically you should take a big text file and that formatted along this lines and count how many unique names there are. So for this, I don't want you to use a list or a dictionary. I want you to try to do this with a set. So how would you do this with a set? All right, well, since sets don't allow for duplicate values in them, a set is actually a great data structure to use to solve this problem. What we can do is create our empty set, open the file, read through the lines and so on. But if we just take every name and just say add to the set, even if a name shows up a bunch, right? If Chris Paul shows up multiple times, it will only allow one of those Chris Paul strings to stay in the set because duplicates aren't allowed. So by the time the loop finishes and we go to print out the length of names, let me reset. In our names set, right, by the time we get to the end, none of the duplicates will still be there. All of the duplicates will have been eliminated, and every name that was in the file should only show up one time, at least the pairs, first and last. And so we'd get the actual count right there. So I can run a quick test. So let's create a file, call it names.txt, probably have to overwrite. And let's run this code just to make sure it works. And there we go. It says 11 as the answer. Now, another kind of follow-up to this is what if I asked you to solve basically this same problem, but not where you're not allowed to use sets or dictionaries. In other words, you need to use a list in order to accomplish this. And the idea behind this, I'm going to also ask you to do it without using a set or a list. The idea behind this is to kind of compare, what if I have to solve a problem with only a set, with only a dictionary, with only a list, which one is the best option? So how would we do this if we had to basically not use a set and use a list instead? Well, the way we could do this is, it's a little bit more code, but not too bad. If we start with an empty list, we can append the names to a list, but in a list, duplicate elements are allowed. So in order to kind of eliminate those duplicate elements before we add it, we need to have an if statement to check and make sure that this name is not already in there, right? So if I say, hey, only get to this point where you append if that name that I'm currently at, let's say it's Chris Paul, only if that's not already in there, append it. And then by the time we get to the end again, we can rely on all the duplicates having been eliminated. And this should still work. If I run it, it should still give us 11. So it's just a little bit more code, right? It's really not that bad, just slightly more. Now, how would we do this if you had to not use a set or a list? In other words, use a dictionary to solve this problem. All right, well, if you had to use a dictionary, it's actually very similar to the set solution. Instead of calling the add function, we can just map the name to an empty string. Now, the reason why this works is because duplicate keys are not allowed in a dictionary, right? So I could get to the first Chris Paul and map Chris Paul to an empty string. And then when I get to the second Chris Paul and map Chris Paul to an empty string, it's not going to put two Chris Paul keys in there. It's only going to keep one of them. So this is actually the same number of lines of code as the example with the set data structure. It still gives the right answer, right? So we have solved a problem with 3 different data structures. You know, the list one was 1 extra line of code. The dictionary one was the same number of lines of code as the set one. But sometimes when you're writing code, you're going to want to, if you have a problem where you have data and you need to analyze that data and do stuff with that data, you're going to want to, at times, take time to think about, well, what's the best data structure to solve my problem? What's the best way for me to store this data, for me to organize this data, or for me to, what's the best structure for me to put this data in? And sometimes the best answer depends on what are you trying to accomplish? What is your program actually trying to do? Because depending on the goals, maybe you don't need things sorted, or maybe there's another scenario, not this one, right, but some other program you want to write where maybe sorting is important. Or maybe you do need some kind of associativity of keys and values, or maybe there's a case where you don't. Like this case, we don't really need that. Over in this case, we still had associativity, but we were just mapping the names to empty strings, right? So it was kind of an unneeded feature of a data structure to solve this problem. So when you're going about trying to solve problems that involve data and data structures, spend a little bit of time trying to make sure you're picking the right data structure for the job. Now, in a future video, I'm going to go through an example. I'm actually going to implement kind of a simple thesaurus program. And sets are going to be useful there. We're going to actually kind of combine a dictionary with sets. We're going to actually have sets as the values that the dictionary keys are mapping to. And so that's going to be a place where a set comes useful. So anyway, I hope you found that video helpful, and reach out if you have any questions. Have a good one.